Hi all, so in this video we are going to learn about the implementation of stack. If you remember in the earlier video we have seen stack as an ADT, okay? And when we say that stack is a abstract data type, so what do you mean by abstract data type? So for this we need to have the data plus the operation that can be performed on the data, okay? There comes two things for that. First is we need to declare the data. Okay. So when we have to declare the data, then definitely we need a storage space to store the data. Okay. So first thing is the storage. And second thing we talked about is we need a variable that is known as the top variable that points to the topmost element of the stack. So let's see how we can implement these two things. So the very simplest implementation of stack can be done by using an array of fixed size length. Okay. So for this we take an array and we already know that for array we have static memory allocation and array have fixed memory allocation. So let's say the size be n. Okay, this is the representation. So if we have to declare a stack of size n, we declare it as int. Let's say the stack inside the stack we are storing the integers. So let's say this is our stack. So this is the declaration for the stack. For the variable, we take the top. Let's take it as int top. And we initially assign this value to -1. Now, why we initially assign this value to -1? Because we already know that when we take an array, the indices start from 0 onwards. Okay, so let's say that we have an array, let's say of size n equal to 5. So definitely there can be 5 elements that can be stored into this array. Okay, and we for each element there has to be a fixed index. So the very first element would be stored at index 0. Okay, but we already know that top points to the topmost element of the stack. So when the array is initially empty, that is there are no elements in the stack, then the top must point to some position where we have no element. I mean, it shouldn't be pointing to somewhere at 0 or 1 or 2 or 3 or 4, because all these contain the elements, right? So the initial position should be -1. So whenever we have to insert a new element into the stack, the top has to be incremented and the element should be inserted here. When an element is deleted from the stack, let's say we have element 2, 3, 4 here, and our top points to this 2, then definitely if we have to take the topmost element of the stack, I mean the 4, then the top has to be decremented to pointer 1. Okay, index 1. Let's say we take out the 3 also, that is the topmost element, so we take up the 3, so the top would be pointing to 0. Okay, so this 0 index is the topmost element of the stack. Let's say we have to take this 2 also, so the top would be pointing to -1, right? So the top equal to -1 suggests that there are no element in the stack. Okay, so that is why we have initially set it to -1. Okay, so this is one thing, and so these are the declaration of data. How do we declare the data inside the data structure? Now let's see about the operations that can be performed on the data structure. We already have seen that the operation could be either push or pop. So let's or is empty or is full. So let's talk about how we can perform the push operation on the stack. Okay, so when we are trying to push an element into the stack, we definitely need the stack. Okay, we need the size of the stack, then we need the top. Of course we will use the top. With the help of top we can push an element, insert an element into the stack, and then we need the element x. X would be the element that needs to be inserted. Okay, so you got this. This is the stack, this is the size of the stack, this is the top pointer, and this is the element that has to be inserted. So when we try to insert an element, we need to check whether our stack is full or empty. So let's suppose our n equal to 5 and we have all the 5 slots filled up. Okay, so if we have all the slots filled up, like starts from 0, 1, 2, 3, 4, and up to 4 we have the elements, then definitely we cannot insert any other element into the top of it because it is already full. So this is a condition of overflow. So first we will check if top equal to n minus 1. That is, if top points to this part, fourth index, then definitely it suggests that the stack is full. Okay, so if this is the condition, we are going to print to the user that it is an overflow condition, and when there is an overflow, we cannot insert any more element into the stack. Now, here we are trying to implement the stack using the array. So we have this restriction over memory, like we have this 5 slots or 10 slots or 100 slots. Let's say if we have we don't want that kind of restriction, so definitely we would go for the dynamic memory allocation. That is, we can use the linked list, or apart from array we can use other data structure for storing the elements, or maybe we can have this size equal to 1000 or something, like, so that it doesn't get over full. Okay, this condition never comes up. Okay, so that depends upon the users. Okay, now, else if we have elements or no elements, so what we are going to do? So first we are going to increment the top, because we know already that if the array is entirely empty, that is if the stack is empty, the top would be pointing to -1. So we need to first increment the top, and then we need to insert the element at the top of the stack. Okay, and this is how we can insert an element X into this stack. Okay, so this is the basic overflow of how we can push an element into the stack. Declaration is very easy. Declaration is just this: you have to get an integer array. Since we are storing the integer, so we create an array of size n. We make a variable top that is initially assigned with value -1. Then we define certain operations, like we have push. This push operation will be inserting an element into the stack. The second operation we have is pop. So this is the pop, and the pop operation always returns the element that gets popped. Okay, so the element that gets removed will be popped up. Okay, so that is why the return type would be int, since we are playing with integers. Okay, so int pop, and then we are providing the stack name, the size of the stack, and of course the top. Okay, so now in the pop condition, there could be a condition where we have no elements in the stack, so that if top equal to -1, that is there is no element in the stack, then definitely if we don't have an element, what will be popped out? So we are printing that it is an underflow condition. Okay, it should sound as u. Okay, and underflow condition, right? So this is one of the condition. Otherwise, if there are elements in the stack, then what we are going to do? Our top is pointing to the topmost element of the stack. Then definitely we need to pop out the element. So let's say we have this integer x, and for integer x, for x we are assigning the top, so s of top. So this is a variable that will hold the topmost element of the stack. And of course, since we have taken the topmost element into X, and we need to pop it out, so definitely we need to do what? Top minus minus. So now the top points to the next element in the stack, that is it is pointing just back. So for example, if this is a stack and there are two elements 1 and 2, and let's say the top points to this position, I mean index position 1. So let's say we have this x variable, and in this x variable we made this s of top, that is s of 1 is 2, so we put 2 into it, and we moved our top to this position, so top points to now 0. So this is our topmost element in the stack, right? So this is x, so x will be equal to the topmost element that we have taken out, and now the top has been moved to this position. So now if the again pop operation will be called off, so this will be popped out. Okay, so this way gets it works, and then we are returning the popped element, that is x. So that is it, right? So yeah, you can write this as x equal to s of top minus minus. So that the top is first assigned to x and then the top gets decremented. Okay. Similar way, if we want to write this operation, so we can do this as s of top equal to, we have to insert x. So we first increment the top and then we assign that x to that position. So this is just an application of the postfix and prefix operators. Okay, so this way we can perform these two operations, right? So these are the basic operation. Then there are operations like is empty. So if you want to check that whether it is empty or full, so there is one operation. So for checking this is empty, we just have one operation, that if top equal to -1, then are saying that the stack is empty, or is full. If we have to check, then we are checking that if top equal to n minus 1, okay, then it is full. So these are some of the operations that we can introduce on the stack, and with the basic implementation of the array. So this is all about the implementation of the stack as an ADT. Next we are going to see some of the operations, some of the implementations where we need the stack data structure. Okay, so that's it for this part. Keep watching. Thank you very much.